Welcome back to the another session in Design and Analysis of Algorithms, Unit 2, Topic 7, Traveling Salesman Problem. So this problem is to discuss about the tour cost of this traveling salesman using brute force approach or brute force method. Let's talk about what is this traveling salesman problem and what is brute force method. How can I apply brute force method to solve the traveling salesman problem? Let's start. So traveling salesman problem is what? We will be given with n cities. The salesman will start at specified city and visit all n-1 cities only once, and he'll return back to the starting city. This is what the traveling salesman problem. Now the objective of this is what? To find the route through the cities that minimize the cost and maximize the profit. So here the cost is what? The edge which is existed in between two cities. Let's suppose that I have two cities, that I am representing the cities with the AB, and we will be representing the whole problem in terms of graph. So I am taking two vertices and one edge. As far as this problem is concerned, we used to tell these are what? Two cities having one edge. This edge is having some cost. Assume that it is of 5. So to travel from A city to B city, the salesman will take 5 as the cost of it. Now once he visits the B city, he'll come back to A city again. Now the thing is what? We will be going to solve this problem using many algorithm techniques, which are brute force, dynamic programming, backtracking. As far as second unit is concerned, we'll find the solution using brute force approach. Now we'll take some example to understand in detail. I'm taking one graph, and this graph I'm going to represent what exactly traveling salesman problem. So here all the vertex are represented with the cities. That means A, B, C, D are represented as cities. Now this is what the edge, right? Path in between A to B. So now this is what I'm assuming as 5. As I told in the previous example, that A to B is what? The cost is 5. To travel from A city to B city, salesman spending the cost which is 5. From B to D he'll travel with the cost of some 6. D to C he'll travel with the cost of 8, and it is 9. And that whatever cost I'm just taking, it is my assumption I'm taking to explain you clearly. So this is what the problem of traveling salesperson. Now he wanted to visit all the cities. How many cities I have? What is the n value? N value is what? My total cities. So n is equal total cities means 4. How many cities he has to visit? n-1 city, and that also only once he has to visit. Once he visited, he should not go back to that city. So n-1 city, the condition is what? The one more condition. He should return back to the city from which he started. That means if he started from A city, he can travel to B city, later to C, later to D, and he should return back to A again. So this is what traveling salesman problem. Now the thing is what? We are not having only the way that A to B, B to D, D to C, C to A. There are many ways to travel from A to other cities. Correct? Now we'll see first of all brute force method, then we'll go back to the traveling salesperson problem using brute force. Now what exactly brute force method is? Brute force method is a straightforward approach in which we'll try all possible solutions systematically until the correct one is found. So this is what brute force method. We'll try all possible solutions. Now how to apply brute force on traveling salesperson problem? That is, get all the routes from one city to other city by taking various permutations. Once after we find all the possibilities from one city to all other cities, from all the other cities to the one city, after taking all permutations, we'll compute the route cost for each permutation and select the minimum one, that is shortest one. So basically we will be going to do this thing with exhaustive sequential search, and that is nothing but we'll compute the cost of all the tour and we'll select the tour which is having minimum cost. Okay, now we'll take some example and we'll solve the traveling salesperson problem. So assume that it is what this question is of previous question paper. Okay, and so there is a question which is solve the following traveling salesperson, which is represented as a graph. Now here all the vertex are represented as cities and the city names are A, B, C, D, and the distances between various cities are represented as numbers, right? Now the solution, how to find the solution for that problem. So first of all you have to consider a source station or the city from which salesman is starting, that I am assuming as A. So it is not given anywhere as a constraint that you can start from only A. You can start from any city, saying that it is your first visiting city. Now, so before I take all permutations, I'll take some adjacency matrix. So adjacency matrix for this graph. A, B, C, D. Now let us see the cost. A to A, there is no A to A, so I am marking it as 0. A to B cost is what? A to B cost is 3. A to C cost is what? 6. A to C is 6. A to D cost is what? 8. A to D is 8. Likewise, you can find all the cost from the graph. I am just moving little bit fast, so you can see all this cost from the graph. Now once after you found adjacency matrix, now consider all the permutations of this graph. The first is what? I am just traveling from A to B, B to C, C to D and go back to A. So what is the cost of A to B? 3 from the graph. From the matrix or from the graph you can take. So the cost of B to C, 9. The cost of C to D is 2. The cost of D to A is 8. So total is what? 8 plus 2, 10. 10 plus 9, 19, 20, 21, 22. So the total cost of this tour is what? 22. Now, so another permutation also you can see and calculate the cost. So the another permutation is A to B to D. This time I am taking D. C to A. Now the cost is 15. The third permutation is A to C, C to B, B to D, D to A. The cost is 27. And A to C, C to D, D to B, B to A. And that is 15. I strongly believe that you are following me how I am writing all this, correct? So because you can see all the permutations over here. You can make a move from A city to other cities by traveling via B, via D and via C. There are many ways to travel, right? So you can take any of the way. Now I am just going for the next possibility or the permutation, which is A to D, D to B, B to C, C to A, and the cost is 27. A to D, D to C, C to B, B to A, and the cost is 22. So these are what the cost to travel this route. Now the thing is what? How many permutations we got total? Earlier we were taken A to B, B to C, D to A. That is 1. Which is 1? A to B to C to D to A. That is A to B, B to C, C to D, D to A. It is 1 permutation. The second is what? A to B and B to D, D to C and C to A. That is the other one. So if you see all this permutation, total 6 permutations we got. Condition apply that my starting city is A. If you take city B also, you'll have 6. But I said that the starting vertex is, I told that starting vertex is A, right? So total permutations for this is what? 6. Now we'll calculate the complexity of this, or else we'll analyze the algorithm. So now we will be analyze the algorithm. Assume that I have n is equal to 2. That means how many cities I wanted to visit? Only 2 cities. Name that A and B. So now how many permutations I will have? Only one permutation, correct? And that permutation is what? A to B, B to A. And assume that n value is 3. Then A to B, B to C. And this is what? How many routes I can make? 2 routes. One is A to B to C. And again C to A. Return back to the starting city. The second is what? A to C to B to A. How many routes you can find? 2 routes. Correct? If n value is 4. If n value is 4, then A to B, C, D. Just now we were taking example of the same, right? 4 vertex. How many we got? 6 routes we got. So what are the 6 routes? A to B to C to D to A to B to D to C to A to C to B to D to A C D B A D B C A and A D C B A. All these are what? Different permutations, correct? 6 routes we got for n is equal to 4. Now the analysis of this is what? I am taking as n minus 1 factorial. Because I have n value is 2, but I did not visited all this 2, right? N minus 1. How many routes I have? Only 1. That means n value is 2. 2 minus 1 factorial, which is 1 factorial, which is 1. So 1 root. N is equal to 3. Substitute in this 3 minus 1 factorial, 2 factorial, which is 2 and 2 roots. The next, n equal to 4. 4 minus 1 factorial, 3 factorial, which is 6 roots. So the time complexity of traveling salesman problem using brute force approach is what? Big O of n minus 1 factorial, which is big O of n factorial. The time complexity of traveling salesperson problem using brute force approach, function f of n is equal to big O of n factorial. This is what? Traveling salesperson problem using brute force approach. Thank you all.